Hi everyone, welcome to the A.SSE.1 Level 3 lesson. We are still talking about algebraic expressions. Again, algebraic expressions are a mathematical phrase made up of variables and numbers combined with at least one operation. Here are our operations that we are learning just briefly about because you should already know all of this. For addition, that's the symbol. Here are all the words that mean addition. There may be other words that aren't included in here. I do want to point out that there is a difference between more and more than, and we'll get to that in a little bit. But go ahead, study these words. If you haven't seen some of them before, make sure that you know what they are and that they mean addition. Moving on, subtraction. Here are all the words that mean subtraction, and there again might be way more than this. The words less than and less mean different things, and we'll talk about that, similar to more and more than meaning different things. Multiplication. So you guys are so used to using the x as multiplication. We are going to get rid of that for algebra. For algebra, we are going to use this symbol because the x looks like a variable. So we don't want to use the x when it comes to multiplication. All of these words mean multiplication. So you see squared on that list. That you could also do cubed or to the fourth power. Exponents mean multiplication because exponents are repeated multiplication. Squared means that we're doing something times itself. And then twice or triple, all of those mean multiplication as well. So make sure that you know that. Division. Using the division symbol, you guys are used to this one here. We're not going to use that. We're going to get away from that in algebra, and we are going to use the fraction bar. So 1 over 3 is the same thing as 1 divided by 3. So you will see fractions, and fractions mean division in algebra, and in all the rest of your math classes. All right, let's go back up to the more than and more, and then less than and less. The phrases 3 less x and 3 less than x result in different expressions. And same with if I did 3 more x or 3 more than x, they give you different expressions. 3 less x is written exactly how it looks. 3 less means minus and x. As soon as you put the word than in the statement, it flips your entire statement around. So the x and the 3 get flipped around and it becomes an x minus a 3. Same with more and more than. If I did 3 more x, that would be 3 plus x. 3 more than x would be x plus 3. And then also, I'm going to have you highlight or circle or whatever the word from. Because whenever you see the word from, if you say subtracted from, that's the same thing as the word than. So, you might want to put a little blurb in your notes that says something like the words than and from flip, or let's just put reverse your algebraic expression. All right. So if I say 3 subtracted from x, that would also be an x minus a 3. All right, so now we're going to get into actually writing statements based off of these word phrases. And we're going to do these together. So 15 less than, I see this word than, that means that I'm going to do the product of 2 and r before I do the 15 less. So I do product means 2 times r, which I'm not going to write a multiplication symbol in. This is a coefficient, 2 times r. You can just write it as 2r. That's the same thing as 2 times r. Less means minus, and then I have 15. Next problem. The quotient of 3 and the difference of 2 and x. I do not see the words than or from, so I start exactly, the statement goes exactly how it's read. So the quotient of 3, so 3, that means 3, and quotient means division, so divided by, we're using the fraction bar. And the difference of 2 and x means 2, difference means minus x. That's it. Next problem. The sum of 15 and the product of 3 and y. I do not see the words than or from, so the statement goes exactly how it reads. The sum of 15, so sum is 15 plus, and then the product of 3y, that's going to be 3 times y. That's it. Number 4. The difference of 9 and twice a number n, I do not see the word than or from in there, so it goes exactly how it's read. So difference is subtraction, and I start with a 9, and then I do the minus. And then twice a number n means 2 times n. It's just a 2n. I don't need the multiplication symbol in there. If you don't have a multiplication symbol between a number and a variable, that is just multiplication. 5 less 3 times a number n. Since we're writing algebraic expressions, then we know that less does not mean the less symbol. We're not talking about that. That's not an algebraic expression. That would be an inequality, which we haven't gotten there yet. So we're writing an algebraic expression, which means that we know that this less means minus. So 5 minus 3 times a number n, so 3n. We don't switch the order because there is no than or from in that statement. 3 times the sum of a number n and 5. So this means 3 times the whole sum of a number n and 5, so n plus 5. Notice how I put that n plus 5 in parentheses because I'm doing the sum of that, but then I'm doing 3 times that whole sum. So I need that in parentheses there. All right. Number 7, twice the sum of the square of x and the cube of y. So this means twice, 2 times, and we're doing a sum, the whole sum of the square of x and cube of y. So that means an x squared plus a y cubed. I'm doing twice that whole sum according to this statement. All right, number 8, 2 more than. I see the word than, so I'm reversing the order of this statement. I'm first going to do double a number, and it doesn't say what the variable or what number that should be, so I'm going to just use x. If you use a different variable, that's fine. And then more means plus, and then 2 more is plus 2. I need to flip the order because of that word than. All right, number 9, the product of 3 and a number quantity. There is, this should be a number quantity cubed. On yours, it does say that. On mine, it does not. So the product of 3 and a number quantity cubed. There's 2 ways to interpret this, and I would accept both. You could do the product, you can read it like this. The product of 3 and a number quantity, meaning that just it's a number cubed. Or, I think the real meaning behind this one is the product of 3 and a number quantity, meaning the whole thing cubed. These mean different things. These two algebraic expressions mean different things, but the way that this statement is worded, I think, could be written either way. And then the last one, 4 divided by 2 less than x. But the thing is here is we're just switching the 2 and the x around. So we're first going to start off with the 4 divided by, but now I'm going to switch the x and the 2 around to have an x minus a 2. So now we're going to move on, and we're going to write the algebraic expression that represents the following situations. So for this, Tim ate 4 more cookies than Alice. So I'm going to do T represents Tim. He ate 4 more cookies than Alice, and if you read further, it says if x represents the number of cookies Alice ate. So Tim ate x plus 4, because I see that word than, so I'm switching the order around. And Bob ate twice as many as cookies as Tim ate. So we want to write the expression that represents the number of cookies that Bob ate. So Bob ate twice the number of cookies that Tim ate 2 times. This is what Tim ate. I cannot write it as 2x plus 4 like this, because that would just be multiplying the 2 times how many cookies Alice ate and then adding 4. I need to multiply the 2 by all the cookies Tim ate, which is that whole x plus 4, so I need that all in parentheses. This is how many cookies Bob ate. Number 12, Mr. Martinez orders 250 keychains with his athletic team's logo and 500 pencils printed with their web address. We want to write the expression that represents the cost of the order. Now, it does not say whether the keychains or the pencils cost the same, so we are going to assume that they do not. I'm going to represent the cost of a keychain being K and the cost of a pencil being P. If you use different variables, that's completely okay, but please do not make keychains and pencils the same variable because we do not know that they cost the same. They might cost differently. So using different variables means that they had a different cost. So if I do $250 times the cost, 250 keychains times the cost of 1 keychain, that would give me the total cost of all the keychains together. And if I do 500 pencils times the cost of 1 pencil, that will give me the total cost of all the pencils of the order. And so if I need to find the total cost of the entire order, I just need to add the 2 costs together. This is my expression. All right, next one. If n plus 4 represents an odd integer, the next larger odd integer is represented by what expression? Let's think about this. I want you to think of an odd integer. It does not matter which odd integer you think of. I'm thinking of the number 7. The next odd integer in that sequence would be 9. How do you get from the number 7 to 9? Well, you add 2. So if I had the odd integer n plus 4, I would need to add 2 to that odd integer to get to the next large odd integer. And so now combining the 4 and 2 together, I get an n plus a 6. That is my next larger odd integer. All right, the last problem. The dog weighs 3 pounds more than twice the cat. We see that word than. That flips the order around. So we want to write an expression for the dog's weight, letting C represents the cat's weight. So we want twice the cat's weight, and then more means plus 3 pounds. That is how much the dog weighs. Notice how I did not use equal signs in any of these because I asked you to write expressions, not equations. Equations have equal signs, so if you used equal signs, please erase them. Where that would be a major error. I don't want equal signs because you need to know the difference between an expression and an equation.